Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about integration 10G. So let's go student, look at the board. So student, question number 66. Now here we can write 0 to ln 2 1 by e to the 1 by 1 plus e to the power x dx. Now student, let 1 plus e to the power x equals to z. Now let 1 plus e to the power x equals to z. Now differentiating with respect to x. So you have learned, student, ddx of 1 equals to 0 and e to the power x equals to e to the power x. Now dx equals to dz. I say again, student, ddx of 1 equals to 0 because constant is always 0, and ddx of e to the power x means e to the power x. Dx equals to dz. So we can write e to the power x dx equals to dz. Now change the limit. Then here value of x and find the value of z. Now here upper limit x equals to ln 2. Student, please look at the board. Here if x equals to ln 2, then find the value of z. Now putting the value of ln 2 in this equation, so we have 1 plus e to the power ln 2 equals to z. So 1 plus e to the power ln x, student, using formula e to the power ln x equals to x. So we can write e to the power ln 2 equals to 2 equals to z. So z equals to 3. So student, if x equals to ln 2, so value of z equals to 3. Again, if x equals to 0, so we have here putting the value of x equals to 0. Now we get 1 plus e to the power 0 equals to z. So 1 plus 1 equals to z. So value of z equals to 2. So student, if x equals to ln 2, then we get z equals to 3. Again, if x equals to 0, then value of z equals to 2. Then student, here putting the value of lower limit is 2. Lower limit is 2 and upper limit is 3. And now putting the value of 1 by e to the power x equals to z. So putting the value of 1 plus e to the power x equals to z, and now here e to the power x dx, e to the power x dx equals to dz. Are you clear, student? I say again, putting the value of 1 plus e to the power x is z and e to the power x dx equals to dz. Now using integration formula, we know that 1 by z dz, integration 1 by z dz equals to ln z. You have learned, student, integration of 1 by x dx equals to ln x. So here using formula 1 by z dz is ln z plus ln z. So here lower limit 2 and upper limit 3. Now putting the value of z is 3, ln 3 minus ln 2, and we know that ln a minus ln b equals to ln 3 by 2. So answer will be ln 3 by 2. I hope that, student, you are clear. Question number 68. Integration of 1 to e to the power x e to the power square. Here lower limit 1 and upper limit is e square, and 1 by x 1 plus ln x into dx. Now student, next line 1 e to the power upper limit e square and lower limit 1, then we can write 1 plus ln x 1 by x dx. Now let 1 plus ln x equals to z. So student, attention please here, 1 plus ln x equals to z. Now differentiating with respect to x. Now differentiating with respect to x. So we know that ddx of 1 is a constant. So ddx of 1 is 0, and student, here ddx of ln x equals to 1 by x, dx equals to dz. So we have 1 by x dx equals to dz. Now change the limit, and here student, it is important conditions. If x equals to e square, then find the value of z. If x equals to upper limit e square, then x equals to e square, putting the value of in this function. So we have here 1 plus ln e square equals to z. So attention please student, here 1 plus, then take it to the power first position, and we can write ln e equals to 0. We know that ln e, what is the value of ln e? We know that ln e equals to 1. So value of z equals to 1 plus 2 equals to 3. So we have value of z equals to 3. Student, here if x equals to e square, then we have value of z equals to 3. Again, if x equals to 1, lower limit 1, then we have here 1 plus ln 1 equals to z. We know that ln 1 equals to 0. So value of z equals to 1. Then we have student, here if x equals to 1, then value of z equals to 1. So here lower limit is 1 and upper limit is 3. And now putting the value of 1 plus ln x. 1 plus ln x means z, and 1 by x dx. Student, here 1 by x dx equals to dz. So student, attention please, this line here lower limit 1, upper limit 3, and 1, then putting the value of 1 plus ln x. Here 1 plus ln x is z, and 1 by x dx equals to dz. Now using integration formula, we know that integration of 1 by z dz equals to ln z. So using formula 1 by z dz, integration 1 by z dz equals to ln z, then third bracket lower limit 1, upper limit 3. Now putting the value of ln 3 minus lower limit is 1. Then ln 3, we know that value of ln 1. Student, what is the value of ln 1? We know that ln 1 equals to 0. So value of this is ln 3. So result will be ln 3. I hope that student, you are clear. Question number 76. Now here lower limit 0, upper limit 1, x by 1 plus x to the power 4 dx. So we can write here 0 to 1, 1 by 1 plus x square whole square. X square whole square means x to the power 4, then x dx. So student, let x square equals to z. X square equals to z. Now differentiating with respect to x. So differentiating with respect to x. We know that d dx of x square is twice x, dx equals to dz. So value of x dx equals to half dz. Then take it to the right side of 2. So we have x dx equals to half dz. Now change the limit. So student, attention please. Here x and find the value of z. If x equals to upper limit 1, then find the value of z. If x equals to 1, putting the value of x equals to 1 in this function, so 1 square equals to z. So value of z equals to 1. So student, if x equals to 1, then value of z equals to 1. Again, if x equals to 0, so putting the value of x equals to 0 square means 0, so value of z equals to 0. So here upper limit is 1 and lower limit is 0. Now putting the value of lower limit 0, upper limit 1, and then 1 plus here x square equals to z. So putting the value of x equals to x square equals to z and square, and putting the value of x dx. Here x dx equals to half dz. Student, it is very simple question. Here x dx equals to half dz. Now take it to the first position of half. Then we get 0 to 1, 1 plus z square dz. Now using integration formula, you have learned, student, 1 by 1 plus z square equals to tan inverse z. So we get tan inverse z. Then lower limit, bring the value of upper limit. Upper limit is 1 and tan inverse 0. Now we have here half into tan inverse. We know that 1 equals to tan pi by 4. 1 equals to tan pi by 4, and we know that tan 0 equals to 0. Now we have tan inverse tan pi by 4 equals to pi by 4. So tan inverse tan pi by 4 equals to pi by 4, and tan inverse tan 0 means 0. So half into pi by 4, so equals to pi by 8. So result will be pi by 8. I hope that, student, you are clear. Student, question number 77. Lower limit 0, upper limit 1, 1 by e to the power x plus e to the power minus x dx. It's very important question for your examination. So student, look at the board. Now multiplying numerator and denominator by e to the power x, e to the power x, e to the power x into e to the power x plus e to the power x into e to the power minus x dx. Attention please, student, here multiplying numerator and denominator by e to the power x. Then we can write 0 to 1. Here 1 by e to the power x, e to the power x means e to the power x whole square, and e to the power x, e to the power minus x is 1. Then we have e to the power x dx. So student, here e to the power x into e to the power minus x equals to e to the power x. 1 by e to the power x is 1. So student, here e to the power x, e to the power x into e to the power minus x equals to 1. Now let e to the power x equals to, let e to the power x equals to z. So differentiating with respect to x, we know that ddx of e to the power x equals to e to the power x. You have learned, student, integration ddx of e to the power x, ddx of e to the power x is e to the power x dx equals to dz. Now change the limit. Now we have, student, attention please, here x and z. If x equals to upper limit 1. Now putting the value of x equals to 1 in this function, so z equals to e to the power 1 means e to the power 1 e, and if x equals to 0, so z equals to e to the power 0 means 1, so value of z equals to 1. So student, and now putting the value of lower limit 1 upper limit e, and then z square plus 1, and putting the value of e to the power x dx equals to dz. So we have 1 to e 1 by 1 plus z square dz. So using formula 1 by 1 plus z square, 1 by 1 plus z square equals to tan inverse z, tan inverse z, then lower limit 1 upper limit e. Now putting the value of z equals to upper limit e minus tan inverse lower limit 1. So tan inverse e, then we know that tan inverse 1. What is the value of 1? 10. So we know that tan pi by 4 equals to 1. So putting the value of 1 equals to tan pi by 4. So student, tan inverse e, and then tan inverse cancel, we have pi by 4. Tan inverse tan pi by 4 equals to pi by 4. So result will be tan inverse e minus p pi by 4. I hope that student you are clear. Student, question number 85. It's very important question for your examination. So attention please student. 85, lower limit 0, upper limit 4. So root over 16 minus x square dx. So student, 0 to 4. Here we can write 16 means 4 square minus x square dx. Now student, here using formula root over a square minus x square, integration root over a square minus x square is x root over a square means 4 square minus x square by 2 plus a square, here a square is 4 square by 2 sine inverse x by a means 4. Integration completed, then lower limit 0, upper limit 4. So student, here using this formula, so memorize it student, root over a square minus x square dx equals to x root over a square minus x square by 2 plus a square by 2 sine inverse x by a plus c. This is integration formula. So student, here using this formula, x root over a square means 4 square minus x square by 2 plus a square by 2, a means 4 square by 2 sine inverse x by a means 4. So student, now here putting the value of 4, if x equals to 4, so 4 root over 4 square minus 4 square by 2 plus 16 by 2 sine inverse 4 by 4, and then minus lower limit means x is 0 means 0 plus 4 square by 2 sine inverse 0 by 4, 0 means 0. So student, here 4 square means 0, here 0 by 2, 16 by 2 is 8, and sine inverse 1, 4 cancel, so sine inverse 1, here 0 plus 0. Now student, here 0 plus 8 into, we know that sine inverse 1, we know that 1 equals to sine pi by 2, 1 equals to sine pi by 2. Sine pi by 2 equals to 1. So 1 equals to, we can write sine pi by 2 minus 0. Then we get here, students, sine inverse sine pi by 2 means pi by 2. And 2 and 8 cancel. So result will be 4 pi. So result will be 4 pi. So student, it is very important formula. Root over a square minus x square equals to x root over a square minus x square by 2 plus a square by 2 sine inverse x by a. So memorize it, student. And I say again, student, here using this formula. Now putting the upper limit minus putting the lower limit. Then we get 4 pi. So result will be 4 pi. I hope that, student, you are clear. So see you again next class. Allah Hafiz.